All right, welcome back. We'll be going over more of the circuit, let's say, more of the circuit. I don't know if I'll stop or finish this one. So we just went through all of our operations here. We're now going to be starting here, and we're going to choose which operation we want to send through. And of course, you have to test for all of them, so we'll be sending all of them through eventually, not at the same time. All right. So first things first is we got to start importing all of our waves, of course. We got channel 1 pass is what we're on right now. There we go, channel 2 pass. Excellent, channel 1 invert. All right. Channel 2 invert. Remember, these will be inverted at the end. We got the sum here. Open sum. All right, we're gonna do subtraction, subtract, differentiation. We got so many files now. It's gonna get even larger too. All right, integration. Wonderful. All right, all of our waves are now imported. We got to start selecting which one's going to be going through. We got this mux right here. We've got 8 total options. First things first, it's going to be in binary, of course, which one we select. So we got channel 1, oh, this is going to be 0, 1, 2, 3, 4, 5, 6, 7 for 8 total options, of course. So to get this one right here, which is going to be the channel 1 pass, we got to have this all 0. As you can see, I ended up 8 right there. All right. So this here is all zeros, which is going to be our first choice, which is going to let through channel 1 pass. All right, so let's start simulating here. We'll be simulating for one. I'm going to say micro, but it's a second. Hopefully this is quick. Not too terribly, terribly bad. All right, so there's our pass. And channel 1, of course, was going up. But at the end, this will be, of course, inverted back to its original state. So we need to export this as text, of course, and I'm going to label all of them as out. This way I can do, again, just a mass Excel spreadsheet thing going on again. So we got, I'm going to label all of them out. We're going to label this one channel 1. Go to channel 2 now. All right, same thing. I'm going to have to select channel 2 though, and this is the least significant bit. So there we go. We got 1. Oh, man. I probably have not talked this much in literally a month. I am not sick, I promise you that. I do not have the virus. I haven't left the house in forever, so that's my life now. All right, we're almost done here. Excellent. That's exactly what we were expecting. File. Export as text. This is going to be out channel. I'll go to channel 3. There we go. That's going to be 2 right there. Let's get this going. And yeah, this is pretty much how this is why it just takes so long to just do one of these simulations. All right, guess what we're doing? We're at channel 1. That's done. We got to go to the next one now. 2, 3. That will be this guy right here. Perfect. Okay. Let's get it calculating. We're almost done. There you go. File, export as text. Out. This is the channel 2. All right, we gotta go to the next one. All the most significant bits on now. All right, this is gonna give us the summing. So we should expect what looks like a sine wave coming out, dipping down, of course, because it's inverted for pretty much all the stuff in the middle. There you go, dipping down, sine wave. Some of the other simulations I've done here in the middle, it'll be a little jaggedy. Pretty sure that's because of the number of samples, like especially with the 256 kilohertz ones, are really quick. It's a little jumbled up there, but not this one. This one's nice and smooth. All right, so that's out to the sum. Let's get the sum through. All right, now we're at 5. This is the subtract, so we should be expecting what looks like a rectified circuit, but going down, of course, because we are inverted. All right, wonderful. Bam, exactly what we expect. We're still, again, remember we're at the 2, should be around 2.5 volts. We're just a little bit under that. That's perfect. We're going to export this. Not that. Subtract. Then we'll be doing differentiation. We're going to make this 6. That's 4, 5, 6. Lovely. Let's get this going. Calculated. All right, we are almost done here. And there it is. There's our wave. So it's going to be exported now. Out. And now we're ending at all of them on, which is going to be integration. So let's get that going. Now for this next part, we have to go back to Excel, of course. That's what's going to be coming up next. I'm going to open up all those files that we just made at the same time. We're going to truncate them. We're going to get them back into microcontroller conditioning. And we'll go from there. Excellent. That's exactly what we're looking for as text. Out integration. Wonderful. All right, Excel time. We're going to open up all those files that we just made. So we should look for the out section. There it is. We got the 4 for the pass and invert. We got our 4 operations there on the bottom. We got everything. Start opening them up. Finish. We're almost there. It's like the final stretch right here. All right. So it's that these are named properly now. I'm going to be changing these cells right over here because these are all coming out from the same tab here. They're all coming from operation select, so they name all the same thing. So we're just going to change this one here to out sum, or no, output. Let's do output. Output sum. Excellent. And of course, let's look at how many samples we have. Oh, we got a butt ton. Let's take them out. Excellent. Now this is named output sum instead of that operation thing. Now we're going to do the same thing. Guess what we're doing? Tab delimited. This way that Tina can read it. All right, so sum is done. No, let's not save this. All right, let's do the same thing here. We'll change this to output subtract. We're going to take out those extra samples. We're going to save it as tab delimited. We're going to remove these. Yes, those are done now. We're going to do output integration. We're going to remove those extra samples. File, save as, tab delimited. All right, we're going to do differentiation now. So output, remove the extra samples we don't need. Save as, tab delimited. All right, we got output, channel 2, now. Remove all those extra files so that we can make the simulations 10 times faster. We're going to save it as tab delimited. Those done. Next up, we got output channel 2. We're going to remove those extra data samples we don't want for speed. And then we're going to do what we always do and go and save as tab delimited. Output channel 1 pass. The extra data samples we don't want. File, save as, tab delimited. Save that, channel 1 invert, so output channel 1. We're going to remove all the extra data points that we do not want. We're going to file, save as. You guessed it by now. The name of our project, probably. Tab Delimited Chronicles. That was everything. Now we get to go back to the microcontroller now. We get to go do this. So we selected our operation, and remember this only sends one at a time through. whichever one you're trying to do, but we're simulating for everything, so we wound up doing all possible cases. Now we're going to see how the microcontroller reads all of those cases. And let's do that one in the next video. I think this is a good place to stop.